How's it going, everyone? Welcome. Hilario Gonzalez. That's right. We're going to talk about is now the functional JavaScript, or aka this functional programming, and why this is important, the value proposition of this, and dive deep into these techniques and tools that we have on the language that allow us to make is the code provable, and follow this particularly approach when it comes to now write our application in this functional way. This is something that is not new in programming language. It's just a set of tools that we can hold in our tool belt as a way to, when it comes to write certain kind of applications, we can use this particular pattern, and this is the tool that allows us to work with. So because there is a reason why, for example, we use object-oriented programming, because functional programming is this fundamental view of the world, which is something that Grady Butch eloquently described in an interview, right? So you got Grady Butch and the history of software, engineering. I think this is something. That's right. There you got it. From the Pragmatical podcast, the Pragmatic Engineer. Here I am. This is also the reason why we actually are looking and exploring this kind of idea as a way to understand how do we get here. And once you do that, you will embrace the complexity. So here, Grady Butch eloquently say, for example, at least in this podcast,
the entire history of software engineering is one of rising levels of abstraction. So what we're seeing here is the rise of another level of abstractions, which gives us all these extraordinarily powerful frameworks from which I can build systems, and which, as I alluded to, the architectural decisions that were front and center for us back then are now embodied in these. So now it becomes a decision: what cloud service do I use? What messaging system do I use? What platform do I use? That's the decision, which has a lot of economic decisions and not just software kinds of decisions associated with it. So I think the role of the architect, in effect, has changed. Because now I'm dealing with systemic problems, not just software problems. So.
And that's another interesting topic. Again, I know this is something that goes beyond the scope of this. So at some point you need to provide your experience and services to a company or a business. That's exactly what a lot of them are actually looking for. Is looking someone that, hey, can you pick up the right different tools here available on the market, so we can build that to fit our needs. So this is more in an economic incentive rather than software problems. Again, and I know this is the 50,000 foot view of this, but as a programmer, as someone who now solves problems with code, looking at these two particular way of solving problems is with the functional approach or the atoms. Okay, this is now the reason why it's quite important to actually look and explore here, at least in a practical approach, with Kyle Simpson, which is the software. It's a software engineering. He previously worked at Vela, a particular startup venture. But here now, focus his attention is to understand, is to make all of these abstract concepts meaningful to our language when it comes to work with them, especially in JavaScript, especially on the web. Now, so the goal of this is to get a conceptual understanding. No, this is not what it is. Sorry. So the goal of this is something that we are going to, let me actually write that down.
Welcome.
Right.
Nice library. I'm going to
Let me actually write it down. as a way to get this. So learn to apply functional programming concept in JavaScript to make your programs more readable and less error prone. So this is the value proposition of this, right? So learn to apply functional programming. So learn to apply this particular tool, this approach. Learn to apply functional programming, similar to the OOP, and then we're going to explore now why is the functional programming and the OOP actually born, because with functional programming or processes, this is now how we fundamentally look at the world. Do we look at the world through processes or through atoms? And even though that you can describe a lot of this application in a processes way, in an algorithm way, one step after another, the thing here is that on the real world, most of the time when we need to recreate or build or design stuff, we need to look at their basic building block or their atoms. So it's interesting because programmers on Fortran and those procedural language now has embodied, even in their code, find a way to now group is the data with the functionality. And this is why now the object-oriented programming kicks in, which has become now popular and heavily used now in applications, for example, a financial service, defense service and financial service, where they use now Java to run their servers in, whether it is Java or most of the time it's Java, right? So Java or C, C++, C Sharp, to actually now navigate is how can we describe the world of transactions in the financial worlds or in the defense, and then create now an application that allows to automate that particular process. So because sometimes we need to look at the functional approach to actually solve a particular problem, unlike the object-oriented programming. Okay, that is the focus in this video, in this series of videos, is to learn to apply functional programming concepts in JavaScript, JavaScript to make our applications, to make our programs more readable and less error prone. Okay, so because of that, and I just want to briefly bring this small snippet just to understand how do we get here. Bear with me. I know that this might be quite heavy, but it will be just for 5 minutes to understand now is the Bush method and the evolution of the field of software development. It'll be now only 5 minutes, all right? Please.
So I alluded to a phase I call the first golden age of software.
What is eluded? Eluded meaning? I think it's like evasive. Eluded. Escape from or avoid, exactly. I eluded. Okay, I eluded.
This is the realm of the time of functional, or not functional, but algorithmic languages such as Fortran and COBOL.
Let me actually go a little bit more back.
Truly, you name a domain.
Exactly.
Taking bombers over the Arctic and coming into the United States before we had satellites and pervasive radar. And that was the system.
I don't know if you can see that. Can you? Yep, you do. All right, good. Fair use.
It was that precipitated the creation of what we called the software crisis. It was what triggered the creation of the creation of what we called
Oh, that's right. Okay.
software crisis. It was that it's
Okay.
bonkers.
Just a little bit of his.
Computing was born from World War II and the Cold War, particularly a system called SAFE, the semi-automatic ground environment, that came about during the 50s and indeed was operational until the 1980s. This was a system built in response to the Soviet threat of them taking bombers over the Arctic and coming into the United States before we had satellites and pervasive radar. And that was the system that precipitated the creation of what we called the software crisis. It was what triggered the creation of the NATO conference later in that decade, in which a group of folks came together from around the world saying, how do we attend to this problem? And it was really at the peak of what I'd call the first golden age of software engineering. So we have defense systems. I work with a lot of real-time systems, everything from pacemakers to subway systems to, gosh, what else? CT scans and the like. Truly, you name a domain, and I've probably spent some time in it. The James Webb Space Telescope currently uses the UML in its design. That's pretty freaking cool to think about.
Jumping way forward, you've now been working with a lot of companies, been involved in a lot of projects, and also influenced a lot of software architecture, the broader field. How would you describe the field evolving over the decades? You were clearly part of some key techniques invented and becoming commonplace. What was this like?
So I alluded to a phase I called the first golden age of software engineering. This is the realm of the time of functional, or not functional, but algorithmic languages such as Fortran and COBOL.
And this is what is the emerge of this particular language and this particular way of now looking at things to describe that. So I'm going to shut up and move on.
APL, Lisp, and the like, although Lisp was sort of a multimodal kind of language. But the dominant way that we decompose systems was through algorithms.
Make another pause here. The way on how we decompose systems back then were through algorithms. So, in other words, if you want, for example, is to, just a silly example, hey, you want to, if you want to order meal, right, for DoorDash or Uber Eats or any other app that you might use right now. So how you came now is take the whole process of taking the order and then now finding somehow a restaurant that are able to actually produce that, and then use a rider, I don't know, bike or a car or motorcycle, and then now deliver give it to them so you can get that back to your house. So all of this particular process is, well, how you can describe us through algorithm, through functional, most likely through processes.
And so you saw the rise of structured analysis and design techniques, which made a whole lot of sense at that time. This is where you had the Jordans and the Marcos and Constantine and the like, because the presenting problem for software systems was they were generally not distributed. They were largely monoliths. And how could we build larger and larger systems?
Okay, another pause here. The vast majority of all of those applications were monolithic, not distributed, which is something that we right now have to deal with as a JavaScript developers. There is another interesting set of video that I did that based on the asynchronicity and how do we need to handle this particularly approach of dealing with tasks that takes some time to complete, that is not being done in this computer. It'll be done in some other computer at some point in the future, aka in a database or in another server. So move on.
Systems that were sustainable and economically interesting over time. Well,
Mm. And also that they need to be also interesting, economically interesting over time. And I think this is the part of that a lot of software developers perhaps miss the target, is that they're solely focuses on and in love, infatuated with all of these techniques and uh, tactics, strategies from the mathematical world, that they might lose context of the end goal of doing this, which is we want to do this is for economic interest, bro. So that's also so what I can say is you need to combine is in computer science has a very interesting intersection of huge amount of domains, communicational, so analytical, communicational, technical. And technical is everything that you have learned. Do you know the trade-off, or do you really know, or do you just memorize that? Sales, because at the end of the day you need to actually sell the solutions to solve a particular specific problems, to make it sustainable, to make it economically interesting and sustainable. So there is a lot of dimension here, and not to mention is that you have to be you need to pay attention to your body. You need to also invest in your health, right? And your sleep, in your physical, in your scheduled mealing and mealing protocols. You know, there is a lot of dimension here that we, as software engineers, are dealing with, and this is also the reason why I'm actually taking this kind of video to improve my communication, analytical, technical, coding skill, because this is another one. It's not only to tell, so show me, don't tell, but also is the sell, and perhaps I'm not recording this kind of stuff here, but I'm showing that on my YouTube channel about hey, this is my schedule, milling schedule, or this is my sleep schedule as well. This is also the fitness component, and also paying a personal trainer to actually give me some of this fitness plan, and so on and so forth. So again, going back here to what we really care, but I just want to broad that out, which is something that I find out important. So
sustainable and economically interesting over time. Well, the golden age of that first golden age of software engineering began to change as we started to see the rise of distributed systems. And that rise, again, happened not in the commercial world, but it happened in the defense world. The ARPANET was, funded by...
Interesting. This, from the monolithic to distributed systems, happened is on the defense sector. And I think a lot of this, for example, the internet, this actually now happens here in that defense sector. In a lot of the stuff that we're going to see on the defense sector in terms of the automation and robotics is going to move forward at some point that we are going to deal with that. But I think the vast majority of the decision made by the policymakers, our focus is on the automation and the sense of control. In other words, is any technique in the strategy that allows and to give us is control over the material world. So whether it's software, whether it's hardware, or whether it's a particular system that allows to give that, I will argue that the AI is now the new field here in terms of pushing ourselves into the new era that, of course, It will be hugely developed by the defense sector, whether it's on U.S. or China. All right, and then it's going to now pass to the commercial sector. But in any case, go on.
The government funded by DARPA. I was, as I mentioned to you earlier, I got my first email address in 1979.
Holy moly.
When there weren't that many email addresses around. In fact, one small story there. When we had the ARPANET, I was teaching at the Air Force Academy at the time. We had a little mimeographed document that listed the email address of everybody in the world. I think at that time there were a few thousand people, so we knew whoever one was. And it was pretty cool to go back. So the first distributed systems were happening in that domain. Indeed, back to Vandenberg, I worked on a system called the Telemetry Integrated Processing System, which was a close network of some 32 mini computers. Mini computers were beginning to be a thing. And so the problems of how do I deal with taking a larger system and breaking it up into multiple distributed parts was beginning to emerge. The problem hadn't reached the commercial sector yet.
Exactly. This is something that how can I break down, and this is on the defense. Okay, so how can I break down is this system into multiple, or broken down into multiple different unit of processing, aka microprocessors back then, or PCs, or computers, or servers. Now, all of this, for example, the techniques that as a JavaScript developers we know, or the tools to handle the asynchronicity. So, for example, is the callbacks, the thunk, which is a concept that now way predate JavaScript, and it was designed here as a way to now eliminate time as a concerning factor when it comes to wait for something to be completed. Okay, and then now we have something called as promise. In what are the trade-off of promise? Generators, iterators, observables, and now the CSP, which is a command sequence, which is something that I'm still exploring that, of course. But this is command sequence processing as a way to now is model is series of eventual values, like in a channel way. Again, all of these different techniques that I mentioned before, right? So CSP, observables, generators and iterators, the promise, thunks, and callbacks is just part of the set of tools that we can use when we need to deal with the asynchronicity in our application, at least in JavaScript. All right. So, because the reason also of taking notes and looking at Grady Bush, shout out to Grady Bush, Jesus fucking Christ, is to now look at the techniques that allow us to now write applications that are less error prone and therefore increase the readability in our application. Something that when you combine with OpenUDT programming, which is the way of how you can now combine is data and its functionality into the same bundle, all right, is two different approaches that allow us to now write applications. And this is something important, especially if you are a UI specialist, because frameworks like React actually are heavily used in this particular paradigm when it comes to now write user interface. So we are actually, in fact, user functional programming. And I just want to move on a little bit here until we reach to the evolution of the field of software development, so that we can now go back to what we really care of functional programming. So yes, I'll shut up. Please, Grady Bush, go on.
So we saw we, the industry, began to see that there were limitations to what one could do with algorithmic decomposition. And so there were these pressures all around to try to attend to the next kinds of software. Software that was distributed, software that was real-time, software that was multilingual, software that worked on a variety of computers. And I had to deal with all the normal aspects of distributed systems, which is they're going to fail at various times, and I've got communication issues and the like. So it led to a realization that we needed to think about software in very different ways. The other thing that was happening is in research, you saw the rise of languages such as Simula and Smalltalk, which were looking at the world in fundamentally different lenses. So here we are again in the late 70s, and again I'm what, a 20-something. I was asked by one of my former teachers at the Air Force Academy, say, Grady, would you go help the Department of Defense figure out how to use this new programming language called Ada so we can apply it to modern software engineering techniques? Now, why was the government worried about this? By that time, software was a real problem for the Department of Defense, actually for all of the federal government, because there were several thousand languages in use that exploded because Fortran and COBOL were useful for some things, but not for all things. And so there was a decision made to build one language to rule them all, and that was the Ada programming language. Ada was far ahead of its time. It was a language that was influenced by Simula and Smalltalk and others, but used the ideas of abstract data types from Liskov and Gauguin and others. It used the ideas of information hiding from David Parnas, all ideas that were very new at the time, but frankly are part of the atmosphere in which we breathe right now. And so, as an industry, we really didn't understand the methodologies to make that work. Thus was born the Booch method. I was
This is interesting, and this Bush method is now, because now we have this particular language, this particular approach of how we can now build this kind of applications. We have now the tool, but we don't know how to do that, right? So let's go to explore a little bit of the Bush method, and then we move on to that.
About 81, I was going back and forth across the United States, helping the federal government and helping contractors try to apply this new language in new ways. And this was the beginnings of the second golden age of software engineering, in which it was not so much the complexity of the algorithms, but it became a systems engineering problem, systems that were dealing with distributed systems that were very new at the time. And that was the essence of the Booch method, was the things I learned about helping organizations architect systems with these new kinds of domains and new kinds of languages.
Could you explain what the Booch method is? I understand it has to do with object-oriented programming, but coming from you as the person who invented it, it would be nice to explain what it is and why it was important.
Well, let's go back to Plato.
Holy moly.
Going way back. I wasn't around then, but I've read about it a little bit. There's this wonderful treatise he wrote, The Dialogue, in which there's a debate about how one should best look at the world. Should I look at it as atoms, or should I look at it as processes? Well, the first golden age of software engineering was more focused upon the processes, the algorithms. But there's a parallel way of looking at the world, and that's looking at it through the atoms, if you will, the classes and objects within them. So yes, I was influenced by abstract data type theory, by Plato, by a lot of other interesting philosophical things that were coming together at the time, but were looking at the world in fundamentally different ways. So the Booch method was really trying to codify that. How can we decompose systems not based upon algorithms, but how do we decompose it based upon classes and objects? And again, that's where I was influenced by Liskov and Parnas and Dijkstra and Bohr and the like. Names that are probably unfamiliar to students these days, but they were representing the theoretical underpinnings of the first and second generation. The Booch method was basically saying, hey, here's a new way of thinking about the world. And so it said, look not at algorithms, but look at combining data and processes, algorithms together in one thing. thereby classes. Now, we did some things right, we did some things wrong.
Exactly, but the idea here is to combine is now the data and this algorithm and this functionality here.
The things we did right was classes make a lot of sense in terms of abstraction. What we did wrong is we overemphasized the notion of inheritance. Inheritance was all about let's save code because we can build generalizations and the like. That proved to not make a lot of sense because we ended up doing lots of disparate kinds of abstractions. That's okay. Fast forward to today, and people say, well, what difference does it make? The answer is, it's part of the very atmosphere in which you breathe, so you don't even think about it. You look at, Redis, and you may build things upon it, but if you look at it, you're really dealing with a set of abstractions that Redis offers you, and those abstractions are class-based. So they're baked into the way of thinking of those kinds of systems. So in short, the Booch method was, let's look at the world not through algorithms, but instead objects and classes. The last thing I'll mention is one of the things the Booch system, the Booch method hinted at, that really did not catch full form into the UML, was looking at systems through multiple points of view. Now, we'll come back to that in a bit when I talk about the big picture.
So just so I understand, because myself and most of us listening will have started our careers long after the Booch method was invented. For us, classes, variables, inheritance, that's pretty common or pretty everyday things. But as I understand, it wasn't like that back then, right? So could you talk us through what the environment...
All right, but in any case, I'm going to make a quick pause here because I don't have any... There was a power outage. I'll be right back. And we're back. Now power is on. And all right, fair use. So let's get into actually what we really care in this video. So the goal the course structure of all of this is this. So we're going to look at the introduction, function purity, arguments and adapters, all of this concepts that are part of the tool set that we're going to put out in our tool belt, right? Function purity, arguments, adapters, point free, closure, composition, immutability, recursion. I don't know why it put it in that way, but that's another one. Recursion, list operations, transduction, data structure operations, asynchronicity. Briefly look at the asynchronicity here because we already know what are the tools that are available, and functional JavaScript utils as it is. Now let's get into this. Let's for real. Okay, it wouldn't allow me to write. No, because I don't have any internet. I would like to work. What about now? Yeah, what about now? 2, 2, 3. Really? Okay. What about now? Okay. All right. Isn't there? Okay, now I'm in. All right. And here we are. It's now trying to establish that connection. Nope. Are you? Can you? Would you? Please? Alright, there you go. Good. So let's get into this. Introduction. Alright.
Welcome to version 3 of this workshop. I'm excited about the updates that we're going to have in functional light JavaScript. We're going to be talking over the course of the next 2 days about functional programming, what that means, how to restructure our brains, because it is a very different way of thinking. We have to restructure our brains to think about and try to solve problems in a different way. And if you have never done functional programming before, don't worry. We're going to go from the very basics. If you've done functional programming before, you should be aware that this is not exactly functional programming with the little trademark next to it. It's my brand of functional programming that I call functional light. That's where this name comes from. So this is the name of this course. It's also the name of the companion book of the same name, Functional Light JavaScript. So if you are looking for somewhere to go from here, somewhere to dig into more of the concepts or to get more of the background on something, if we go too quickly through something and you need to go back and review, I strongly recommend digging through that book. Fair warning, even though it says light in the title, both in this course and in the book, it is not an intro, beginner, light and easy sort of a course. What we mean by light is not that it's not deep. Actually, we are going to go pretty deep in these topics. But rather, what I mean by light is that we're not trying to inundate you with terminology, mathematical notation, which is what I would call the top-down approach to teaching functional programming. And I don't know what your experience may have been trying to be exposed to materials, books, blogs, talks, courses on functional programming. But I've been doing this programming thing for a long time. I'm now probably 25-ish years into programming, and almost all of that has been in JavaScript, or at least aware of and familiar with JavaScript. And I have gone to countless talks, read countless blog posts, tried to pick up and read the first chapter of I don't even know how many books on the topic of functional programming. And it always seems to me like the first couple of paragraphs are like, oh yeah, I'm tracking with this, I get this, and then all of a sudden they throw a word in, like a monad or something like that. They'll throw a word in like that, and I'm immediately, because those words don't mean anything in the English language, I'm immediately out of the concept. Some of you may have that same experience. You feel like, wait a minute, I was tracking, and then all of a sudden we just went completely off the rails. Not a little bit at a time, but just entirely off the rails. Or whether it's not, maybe it's not a term, but maybe it's some sort of mathematical equation, or they talk about something like category theory or something like that, and immediately I'm off the rails. I'm losing track of what's happening. So by the first 10 or 15 minutes of every functional talk I've ever been to, my eyes have glazed over, and I'm just barely keeping up. So maybe that's your story, and it certainly has been my story. It's felt to me like running face first into the side of a cliff wall of a mountain, where I kept wanting to, I was motivated, and motivation wasn't the problem. I kept wanting to understand what this functional thing was all about. I remember actually, probably more than 20 years ago, I remember hearing someone, and that would have been early on in my programming career, so I certainly wouldn't have had any sense of what the gravitas, what the meaning of this would have been. But I remember hearing somebody saying something like blah, 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 functional programming. And I remember thinking to myself, oh, I'm good with that because I use functions. And it turns out that I didn't know anything at all about what I was doing. That it turns out that the idea of having a keyword in your program called function, that's not enough. So I decided to write this book And I decided to build this course because, for me, all of the existing materials, while completely valid and totally right, I have absolutely no critique of them other than, for whatever reason, they didn't work with the way that my brain approached things. They didn't align with my background. And I felt inferior about that, by the way, because I do have a CS degree. I have a background in computer science, and I took a lot of math courses, and so it's particularly pronounced that I feel inferior when somebody says, well, it's just math, and I'm like, well, I'm pretty good at math, and I still don't get it. And the reason this course is called Functional Line JavaScript, the reason the book is called that is because I wanted to take, rather than the top-down approach, the bottom-up approach. Speaking of the mountain, the cliff face that I kept running into, and feeling inferior, feeling like I just somehow wasn't good enough, that I was dumb, or that something was wrong with me, I kept having people say to me, well, it's great, and it's amazing, and it's awesome, and I'm like, the problem is not my motivation. I know smart people that know functional programming, and I totally agree with them that it would be great for me to know functional programming. The problem is the path. And actually, the problem is not even the path, the problem is even more fundamental. It's like if you walked up to, I don't know if any of you are rock climbers. Earlier in my life, let's say, I did some rock climbing. I am definitely not a rock climber at this point, okay? But I like the idea of rock climbing. I would love to just be one of those people that could zip up the wall. I watched this documentary the other day, and this guy's like doing this speed racing up the rock climbing wall or whatever. Like, I'd love to do that, but that's not me, okay?
Rock climbing.
But I can imagine the moment walking up to the cliff wall or a rock climbing wall in your favorite gym.
Welcome to the cliff wall.
And somebody who is very experienced in it, who's already up on the wall, up near the top, yelling down at you, just go ahead and grab that equipment and climb right on up. And they point to this pile of equipment sitting on the ground.
They
And
point to the
that's
pile
what
of
it's felt like
equipment.
to be with functional programming is that we start talking about things that make sense to me, and then all of a sudden they say, oh, and by the way, the carabiner, or oh, and by the way, this such and such knot on the rope. And they start using things as if I already know what they are. They start using those terms as if I already know what they are, or they use a process to describe those things that they're assuming that process is already familiar. And that's where I get off. And it would be the same thing if somebody tried, as an experienced rope climber, to explain to me the very basics of what on earth is this metal loop for, that I happen to know is called a carabiner. What is that for? What does it do? How does it work? What are its properties and characteristics? Because what I can imagine is, for the most experienced of the rock climbers out there, they are so far beyond the idea of what is a carabiner that they have forgotten what it was like when they didn't know what a carabiner was. And I don't know if any of you have ever had this experience with something else that you have learned. You're all excellent professionals at what you do, and you probably have, at some time or another, tried to explain to somebody else something that you're pretty good at. I get to do that for a living. It's a particular joy, because it forces me to come back to understand on a regular basis just how easy it is to lose track, to lose empathy for somebody who doesn't understand what you're saying. I do it all the time. I use words, and then somebody looks at me weird, and I'm like, oh yeah, you don't know what that word means. Let me explain what that concept means, right? So it's a joy for me to continue to come back to that, to be confronted with and come back to those roots and ask those. It's been said that if you can't explain something to someone else, then you don't really understand it. But that doesn't fully encapsulate the truth, because at some point you can understand.
You can understand so well that.
Doug Crockford said it this way years ago. He said the curse of the monad. And I'm going to extrapolate that from monad, which is a crazy concept, which, by the way, by the end of this course, we're going to understand what a monad is. But he said the curse of the monad, which I'll extrapolate to functional programming in general, the curse of functional programming is that once you understand it, you stop doing it. And I've experienced that personally on many occasions, seeing people who write these fantastic things, and I know they know what they're talking about. It's not a question of like credential. It's not a question like they're an idiot. Like, they're smart people and they know what they're talking about, but the way that they present it is from the top down, with the assumption that you already have all of that training and
experience and all of the kind of.
And they didn't know what that meant. I didn't know what a dirt was. I didn't know what a rope knot was. And so I kept not benefiting from that material. So this book and this course are my attempt to give you a ground up perspective. Again, it's not a beginner intro. This is deep, heady, difficult stuff, and it's stuff that I still wrestle with, I am still challenging with. So I'm not here to tell you I'm a functional programmer. Okay? I have not arrived at the top of the mountain and now I have all the clarity and I can see everything. That's not this is still a daily struggle that I am trying to understand these concepts and use them more effectively in the code. And I decided to write it down so that hopefully other people might benefit from my exploration, my journey. That's what this course is.
So, the course here, okay. So the intention or or the motivations of Kyle Simpson to write a book called Light Functional Programming, right? That's right, Functional Light Programming. Or is this one? It's Functional Light GS. Because we're going to take a look at this, right? The motivation of doing this. Yep. Okay. Is to so the motivation of Carl Simpson to write a book called Functional Light GS is to boil down his experience as a computer science as a computer scientist is to boil down his experience as a computer scientist in the field of function as a computer scientist. Let me actually break down. Is to boil down his experience as computer science. Is to boil down his experience as a computer science concepts and tools that even though that even for mathematician folks, okay, even for mathematician folks, when they take all of this techniques that even for mathematician fall, when they take all of these techniques and spread the word about it, it is very hard to transmit that to any other computer science engineer. Okay, it is very hard to transmit that to any other computer science engineer. Exactly. It's very hard to transmit that to any other computer science engineer. The top-down model of teaching it is something that assumes that you are quite familiar with these concepts, okay? That you are quite familiar with these concepts and processes, where the reality is that most of us don't. So this is more a ground up approach of functional programming in JavaScript. Let's get into this.
And why functional programming? That's a really key critical thing. And And let me even be meta about it. Why do we need to understand why functional programming?
Okay, well, let me be a why functional programming? Exactly. Let me be a little bit meta.
You're already here. You're already watching this course. That seems like it ought to be too obvious. You have some curiosity, and I'm willing to bet that if we surveyed everyone that's watching right now, we'd get lots of different answers as to why you're here. Why is this the time that you've chosen to invest? Why have you chosen this particular moment in your career? Maybe there's something happening at work. Maybe there's a shift happening, and you feel like you're getting left behind, and you want to keep up. Maybe you've been curious about it. Maybe you're already.
Yep. Maybe our there's a exactly. Let us let us be a little bit meta here. Why we are here? Why we are here learning this? Maybe because you are curious. Curious might be. Okay, maybe because you're curious, or maybe because in your career you might feel behind, quote, or in your company, are using this that you barely understand.
Super experienced, and you're just listening to hear me trip up and make a mistake, and that's probably going to happen too. So there's a wide range of motivations that might be. But I want to give you one that may not be obvious. I want to tell you that one of the biggest reasons why you should learn functional programming and why this should matter, and why we need to discuss that, is because it is impossible, at least in my opinion, impossible for you to write functional programming in isolation. It is impossible for you to go back to work tomorrow or the next day and send in a pull request where you've rewritten a whole section of your code using some new technique that we learned in this course, and then all of a sudden just magically that's going to land in the code and everybody's going to be happy and thumbs up about it. You can't take this journey up the side of the cliff face alone. You're going to have to.
Exactly. So, so one of the reason about this is that this. So one of the reason. One of the reason is this is not a solo journey. Exactly. Because you need to convince the people you collaborate with to use it.
There's value in the journey as well. So while you're sitting here watching this course, you need to understand that whoever it is that you work with now and in the future, you're going to have to be able to convince them to come on the journey as well. You're going to have to convince them that climbing straight up the side of a cliff wall, which sounds crazy, is actually worthwhile. Okay? That's why this conversation matters. Why functional programming?
So you will have to convince why climbing you have to convince why climbing this huge you will have to convince why climbing to this why climbing to the peak why climbing to the peak of the mountain is worthwhile.
I have some thoughts on why functional programming, but I'm sharing these because you're going to have to, almost in a proxy sense, you're going to have to share those with the people around you. You're going to have to convince them. One of the biggest reasons why functional programming, and it's often touted, is that functional programming signals a shift, or it signals a paradigm difference in the way that you approach code, and that can be incorporated in these ideas of imperative programming versus declarative programming. Let's make sure we understand what those words mean, because I don't want to just throw words like carabiner at you and not have them have a definition. What does imperative mean? The good news is, unless you already are one of those unicorns who learned programming from the beginning as a functional programmer, and if you are, I'm envious of you. Okay? But unless you are like that, then you're like all the rest of us, which is that you learn non-functionally, which is to say you learned imperative. Imperative code means code that is focused primarily on how to do
how things work, exactly.
If somebody tells you, I've got a list of numbers that all need to be added up to get a final total sum, just me saying that English sentence means that almost all of you had the same code snippet that popped into your head. If you have any experience with programming at all of you probably conceived something like, I'm going to set up an accumulator variable called total, and I'm going to for loop over the array, and I'm going to add each element into the total and then return the total. And if that's the way that you thought about the problem, you're in good company, because that's the way all the rest of us thought about the problem. And that's the imperative approach, because that code, while it will work, and while it's familiar, and while it's convenient, and while it's probably pretty performant, all of those are good things. But that code is imperative, because the future reader of that code has to read all of the code, and in a sense, almost mentally execute the code before they understand what its purpose is. They have to do that. They can't simply glance at this particular for loop and immediately know exactly what that for loop is doing. They have to read it and execute a few iterations and then convince themselves. They have to imply from the code, infer from the code rather, what it's doing. You may think, well, that's not a big deal. That's what programmers do. We read code and then we write code. Not a big deal. Well, it is kind of a big deal. It is kind of a big deal because it forces the reader to do something that they're not actually naturally gifted at doing.
Imperative and
Guess who's
declarative.
particularly good at executing code? The computer. Who's not so great at executing code? Our brains. They weren't built for that. So any time that you write some code that forces the person to execute it in their head just so they can understand it, is code that's going to be harder to understand, and code that's harder to understand is code that's harder to maintain, to improve.
Mm-hmm. So the point of imperative, which is to describe, and here is when the value proposition of all of this come from, is to describe how things work, how things work, which is efficient for the machine, but with a cost of readability since now another person jumping to the code needs to understand, need to read and understand what that piece of code is doing. AKA, meaning code is hard to debug, hard to read. Exactly, code is hard to debug, to understand, which is exactly what happened to myself. Meaning code is hard to debug, to understand, to enhance. To improve, to fix. Okay. Code is hard to debug, to understand, to improve, to fix. this is it.
So what is declarative then? Imperative is all focused, or almost all focused on how. Declarative stands in opposition to that because declarative says, no, the how is not the important part. The important part is the what, the outcome.
Mm-hmm.
Why?
Exactly. So imperative. And the declarative. The output is what matters. Is what matters. But more importantly, why? You know? So the output is what matters. Why?
I get this question a lot actually when people talk about code comments. Or maybe not a question, but people will just assert things. Some people will say code comments are evil. Anytime you have a code comment, it means the code is terrible. Code ought to self-document itself. I think that's nonsense. Certainly there's a nugget of truth in there, but we've taken it far too extreme. Code doesn't need to self-document itself. Code needs to tell a story. It needs to communicate that story. But it doesn't need to self-document. There is a purpose for code comments. They're not an excuse for not caring about your code. A lot of people will go to the other extreme and say, well, it doesn't matter how bad the code is, as long as there's a code comment and I explain what I was doing, that's good enough. Actually, it's not good enough because most of the time code comments are out of sync with the code. So it's even worse than it not being there. A bad code comment is worse than no comment at all, because then the person spends twice as much time spending it. But on the topic of code comments, and I'm using this as an illustration point of the reason why declarative is useful, on the topic of code comments, my response is always, no, you don't have to remove all comments, but your comment should not duplicate the narrative of what the code is doing. Don't have a line of code
exactly.
that says I++ and then put a code.
Exactly. So your comment should not have duplicate the narrative of your code, since your code is telling a story.
Code comment that says increment I. Okay. I can see that it's incrementing I. I don't need a code comment at something. Okay? That's not the important reason for that code comment. Here's what I want to know from your code comment. Why are you incrementing by 1? What is magical about 1 as opposed to incrementing by 2?
Is that your comment shouldn't have duplicated the narrative of your code, since your code is telling a story. Why your comment? So your comment must describe why it's doing that.
That might be useful information that I want to tell you. That's what a code comment should focus on. It should focus on the why, not the what. And sometimes maybe it needs to focus on the how if it's particularly confusing, if there's something particularly hard to understand. But even in those cases, that's a clue that maybe I could work on improving that code. So that ideally all of my code comments focus on why. But we can go even further than that and say, what if your code made it obvious why it was doing something? Then you don't need a code comment. So I'm not saying no code comments, I'm simply saying shift our perspective from imperative to declarative, focus on, let's allow the system to do what it does best, it figures things out best, and let's focus our code on why we need that. Why we need that what outcome. What is it going to accomplish, and why is that useful? That's what our code should look like. To whatever extent we possibly can. And to the extent that we can't, that's what our code comments should be explaining. You follow me? So we want to shift in this direction, and that is one of the biggest reasons for why functional programming, because functional programming is, by its very nature, more declarative. You notice that I'm couching this in relative terminology because there really aren't a lot of absolutes. It's not like there's a little checkbox that says, oh, functional programming is definitely declarative and everything else is definitely not. That's not how it is. It's a spectrum. It's relative. From whatever perspective you come at that question, a piece of code could both look imperative or declarative. If you've done lots of very declarative coding and then you look at something that's a little less declarative like a for loop, you're going to say that's imperative. But if you've done nothing but ones and zeros or assembly language programming and then you see something like a for loop, you're going to say, wow, that's pretty declarative. You follow where I'm coming from? So it's perspective, it's relative. But to whatever extent that we can shift the focus for the reader of our code towards the declarative away from the imperative, it's going to be easier for them to understand. Not only for them, but also for us. Now, I've shared with you here this highly scientific graph. Okay? This plots out very specific scientific data of my journey of learning how to incorporate declarative techniques in my programming, and my assertion of what impact that had on the readability of my code. Okay? You'll notice that at the beginning, there's kind of an initial win that you start using something, like somebody teaches you something like map, filter, or reduce, or everybody's favorite for each. When somebody teaches you something like map, or filter, or reduce, or everybody's favorite for each. When somebody teaches you something like that, you throw it into code. Now you feel like, oh, my code's way better now. So you start to get these early wins. This is exactly how it went for me. As I started to understand these things, and for me, the journey wasn't writing a book. So I just mapped out a whole book of all these to-do buckets. Giant sections with nothing but to-do in them. Oh, I gotta go learn this, I gotta go learn this. And I would learn it and then try it in some code. I'm like, oh, it's a little easier to understand. Now I get it. So you get some early wins and you start to feel like you're building some momentum. I'm only sharing this journey because some of you may go on a similar journey. Most everybody that I talk to is going on. And you get these early wins, but then stuff starts to get a little more complex, and get a little bit more sophisticated about the stuff that you're bringing together. And eventually you get to a point where the wins are starting to taper off a little bit. You're still using functional techniques. It's not like you've given up on them, but you're not seeing, when you incorporate a new technique, as big of a difference in the readability. Things are slowing down. You're reaching the top of that first curve. And then you throw a few more things into the mix. And, one time you look at some code and you're like, and you look at what it used to be, and you have this thought, man, it was better before. It was more readable before. Some of you, I can see you're smiling because you've been on this curve. You already know exactly what you want. Maybe it wasn't functional programming, maybe it was something else, but you see this curve, it happens. Okay? And it's gonna happen in your journey on functional programming. I'm almost certain. And I'm sharing it with you because I'm trying to not solve that problem for you, but make you aware of this effect and encourage you and challenge you not to give up. Because you keep plunging along and you keep trying new things like I did, and eventually you get to some point like that dotted line that's there. That's about the point where you want to give up, because now the code is worse than it was before you ever started trying to incorporate this new thing. Whether it's a new framework or whether it's this whole new paradigm, functional programming, same thing happens. You reach this point of questioning. Why did I even start this existential crisis? Am I even a programmer? What is this? We all go through that. And that's where many developers give up. And it's where I almost gave up. It was about chapter 2.5 of my book. And I was like, wow, this is really much worse than I thought. It's much more complicated than I thought.
Completely.
It's going to take a lot more time for me to learn and get comfortable with this stuff. This isn't going to be like, oh, I'm done in a few months, and then I get my membership card in the mail, and now I can say I'm a functional programmer. That's not how this is going to be. This is going to be like decades, years and decades of me trying to change the way that I think, to think and solve problems. But at the same time, I still got to ship code. I would imagine most of you, if not all of you, are in the business of being
exactly.
To ship code.
You need to ship code. Exactly. This is also. I wanna make a quick pause here, because it's like, okay, despite all of this philosophical aspect of how you can do this thing, which is great, very, very, very interesting. Talk about all of this stuff that could be or should be or we must do or need to. At some point, we need to be practical here, and that is we need to, given with the tool that we have inherited and now we have developed, do something about it. Ship code. Now provide features that will impact now not only hundreds, thousands, but also millions of lives.
Write libraries that help support all this stuff. I have to still ship code. Every once in a while I work on a side project where I have to ship code. So it's not good enough for me to sit in an ivory tower and think big thoughts about what programming could be if I can't put that into practice.
Exactly.
I would imagine many of you are in the same boat. So you're going to get to that point where you're headed towards the pit of despair, as they call it. You're going to be headed towards the pit of
The
despair.
what?
You're going to be saying, no,
The pit of despair.
as they call it. So you're going to get to that point where you're headed towards the pit of despair, as they call it.
The pit of despair. The pit of despair. Okay. This is now the functional programming journey. Okay. The functional programming. The functional programming journey. And is this one. Nope. Where is it? So the pit of despair.
You're going to be headed towards the pit of despair, and you're going to be saying,
Heading towards.
back up. Go back to where I was doing. And I was there. And what I'm going to encourage you to do is to keep pushing through. Because I kept pushing through. I kept saying, maybe it was from some naivete on my part, but I kept saying, one of these days I'm going to get it. Maybe I'm just a little thick-headed on this stuff, but I'm going to get it. It's going to start to click, and I kept pushing, and I kept trying to add new things onto it, and create new knowledge and new experience, and try it on a different piece of code. And at some point, the bottom of the curve arrived. And one day, I looked at a piece of code that was using a curried composition, or whatever, and it clicked. Just that one line, not everything. It's not like you wake up one day and it all works, but just that one line actually made more sense to me. And a week later, another line of code made more sense to me. A week later, and a month later, and 6 months later. I'm 3 years into this journey of I want to learn about functional programming. The book's been out a year and a half. I spent a year and a half writing the book, so I've been at this 3 years. I'm not at the end of the curve, but it's on a good trend. So it's worth it to keep pushing. It's worth it to encourage your coworkers to keep pushing it. The ultimate pragmatist says, well, it doesn't really matter what the code looks like, just as long as it ships, because that's what I get my paycheck. And I am sensitive to the idea of pragmatism. This whole course is based on the idea that we still have to ship working, executable JavaScript. It's not good enough that it just looks nice, but it doesn't actually work. It has to actually work. It has to do something useful for me. And it has to be maintainable. I got to be able to go back and understand what the heck I was doing. Otherwise, what was the point? So this look at functional programming that we're diving into is born out of this idea of let's not take the theoretical top down, let's take the practical and pragmatic bottom. Let's start with what we know how to do and try to make it a little bit more functional, one piece at a time. Let's look at this pile of equipment on the ground. Let's just figure out what a caravan is. And then let's just figure out how to tie them up, how to put some rope in, and how to take our first step on the equipment. That's it. One thing at a time. And if you do, and keep pushing through and keep trying that stuff, I can't make that not a difficult climb. I don't have the magic to fix that. I can't make it not a difficult climb. But I can make it for you, and this is my hope for the course, that I can make it for you that it's manageable. Somebody can tell you how the equipment works. That's what we're trying to do. Now, there's a tension that I want to call out in this. There's a tension here because and you may have missed it, and that's why I want to call it out. Because I said at one time, no, you got to keep pushing on it. You got to keep trying it, even though it's more confusing. And then at the same time, almost in the same sentence, I said, but you still got to ship code that can be maintained. there's a tension here, because if you only work with code that is familiar and readable and understandable, and anything you do that's not readable and understandable, you just take the shortcut out of, well, I'm a pragmatist, I gotta go back to what works. And you're never gonna advance along that curve. And at the same time, if you advance along the curve and you never connect it back to anything practical and pragmatic, you're going to lose the motivation and you're gonna bail out at some point. So there's a tension here, and I can't fix the tension. I can simply call it out for you and make you aware of and prepared for. At every moment that you take one of these concepts, like what we're going to talk about in this course, and you try to apply it to your code, it is going to happen that it's more confusing at that moment than it was before. This is not yet familiar. So you're going to have to be comfortable in that gray area where it's uncomfortable and feels less readable. And you're going to have to try it not once, not twice, 10 times, 100 times, 1,000 times before that thing becomes familiar. And at the same time, you're going to have an eye towards it. If I want to continue, if I want to sustain the journey, if I want to make it up the mountain, at some point I got to ship code. I got to make a practical choice that at this point in my code and at this point in my journey of understanding, I don't need that thing. A for loop will do. That tension, it exists. You should be aware of it. You should meet it face on. Another interesting perspective on
Okay. So the pit of despair and the tension between going back to what is familiar, and going between going back to what is familiar and keep pushing to understand why we are using it are the two key stuff that we have to deal with.
On why functional programming. This is more from the mathematical perspective. Functional programming, though it looks very programming-esque, it looks like function calls, it's actually math. Now, I don't know the math, and I would guess that at least some of you don't know the math either. But you know what? That's okay. This isn't a math course. I don't need to teach you the math for you to benefit from it. Here's why. I'm sure all of you at some time or another, probably recently, have eaten out at a restaurant, and they brought you the bill, and you had to do some basic arithmetic to figure out what tip to add and how much you were going to charge on the tip. Okay? Now, you probably learned, most of us at least, probably learned basic arithmetic back in first, second, third grade, something like that. And you've been using those life skills ever since. And I'm also willing to bet that the vast majority, if not all of you, have never actually gone through the formal proof of why 1 + 1 = 2. Never gone to that level.
Do the formal proof of why 1 + 1 is equal to 2.
Now, did you know that there's an actual formal proof for it? And did you know that it's amazingly complex to prove that 1 + 1 = 2? I can't even begin to explain the math to you with that. I'm not even shocked. The point is that we're able to take advantage of a mathematical principle even if we can't prove it to ourselves.
Exactly. This is part of the pragmatical approach of doing all of this. Is that if someone already proved that it's true, I just want to use that, and then take advantage of that, which is exactly what I did with, for example, object-oriented programming. So the hard part of object-oriented programming in JavaScript, the asynchronicity in JavaScript, as well as with React and Redux. So to understand that, okay, where all of this come from, and then you embrace the complexity and you take advantage of it. Even though that you need to know at least how the things work or what is the applicability of that, most likely the practical approach rather than how the things work.
1 + 1 = 2. And guess what? We never ever question 1 + 1 = 2, do we? Is there ever been a time where you were like, well, I added 10 and 9 together and I got 9. Is it really 19? I'm not sure. Like, no, you just do it. So when I tell you that functional programming is based on mathematical principles, you can rest on the fact that if you do 1 + 1 and you get 2, That's the end of the story. The math proves it. Whether you can go through the formal proof or not is a secondary issue. Functional programmers, by the way, seem to get a particular joy in life from going through the formal proofs, and that's totally okay.
No, not at all. No.
It hasn't, I should say, it has not yet worked for me. I'm not at that point in my journey yet, where to learn a thing means I need to go learn some mathematical laws and apply it and do some equations. That isn't how I learn this.
No, not at all. And I get it, and I get it.
Advantage of the fact that if I know that this thing done this way has this result,
Exactly.
it's the same thing as
It is like 1 + 1 = 2.
if I do it the right way, I know what the end result's going to be. How many of you have ever written a test in your program before? Anybody done tests? Probably a lot of you do TDD. I know it's very popular. TDD, where you write a test and then you run some code and you're hoping that it passes the test, right? Or maybe do the other way around. You write some code and then you write a test and the test fails. And now you're questioning, is my test bad or is my code bad? I'm not really sure. For me, it's usually both. But, you know, we're trying to get the test to run and we're trying to get it to pass. We want the green. It's a somewhat universal experience for us. Here's what happens for me. Maybe it happens for you. I write some code, and then I go to run the test. I'm not really sure whether it's going to pass or not. I think it will. Hope it will. Maybe. Let's see. Nope, didn't pass. Okay. So what do? I go back, and I wrap some parentheses around something, and I try it again. Nope, didn't work. Okay, and then I add 1 to it. Nope, didn't work. And I just keep fumbling my way through, because if I really understood it, then the first time that I did it, the test would have passed, right?
Mm-hmm.
So we are clearly into
Completely.
territory, this gray area where most of us spend most of our career. We're in this gray area where we only partially understand the problem we're trying to solve.
Exactly.
And you are smart people. You understand some of it. You just don't understand enough of it. Because if you did understand all of it, then it would pass the first
It will
time.
pass the first
Unless you
time.
like, fat finger typos. But most of the
Unless you
time,
have fat
our
finger.
bugs are like logic bugs, where we kind of understand the problem domain, we kind of understand the algorithm, but not entirely. So we fumble our way toward it. This is how I've done almost all of my programming for 25 plus years. So I fumble my way towards something where the test passed. And then I'm like, oh man. And I move on to the next thing. And it's this
No, no, man. No, I don't know. I don't know.
what would it be like?
This is a reason. This is a reason why I say I need to know this kind of stuff, especially if I go to dedicate professionally to this. It's like, yeah, okay, you can at least at the beginning say, oh, this test pass, or oh, this thing's pass, oh. But at some point, you need to understand how that things work, because they're going to affect your life. You like it or not, you are putting time and energy to this, so you better know how those things work behind the scenes. You know, it's like a mechanical that hopefully when they change a tire, don't rip off the chain. You know, and they say, oh God, I didn't, hopefully, whoa, that was close. It's like, you know, you want actually someone that can help you to fix that problem, and no matter how much it charge, please solve this, and do that in the most effective way.
In your program, in your profession, in your day-to-day work, if almost every time that you went to run a test, you were 100% certain of it, what would that do for you? Would you spend less cycles trying to fumble your way through figuring it out? Maybe, hopefully. I'm not suggesting that you would never run the tests, but maybe you'd run them less often. Because you begin to develop a sense of confidence. I know what I'm doing. I'm not an imposter anymore. When I do it, it does the right thing. Maybe that would make you a more effective programmer.
It'll make you an effective programmer.
Why functional programming is compelling is it offers the promise that we can use principles of programming. Not that somebody just wrote about in a blog post or gave a fancy conference talk, but it's based on real hard math. And even if I don't understand the math, I can trust the mathematicians. I'd like to have more of my code like that. I don't know about you, but I'd like to have more of my code in that category of, I guarantee you it's going to do the right thing every time. If I use it correctly, if I legitimately do 1 and 1 and I get 2, I don't have to question that again. That's done.
Exactly.
And that would free up our attention, I think.
And our mind and our times into focus
higher
on.
level important things So
Yeah.
logic and
Exactly.
business domain questions that we should be spending our time on. They free us up for that. And I think that'd be a good thing. It could free up our attention and shift our attention to this. So that's one of the compelling reasons why functional programming. We know that these techniques are not just a nicely designed APIs. In fact, some of them are kind of weird. They're not just about a nice design of an API or a clever name. They're about using mathematical principles in a mathematically sound way. It just happens to look like programming, and it happens to let us solve the programming problem. Ultimately, what I'm getting at here, I think this is the ultimate reason why. Because some people say, there's a lot of different things that people will say about, what is the best code. I would say that the best code is the code that didn't have to be read. And that may sound a little strange to you, but let me explain it this way. There's a code base that has 10,000 lines of code. What if 9,900 lines of that code was based upon proven mathematical principles, and I didn't ever have to second guess any of that stuff, and there were just 100 lines of business logic code that I spent all day, every day thinking about? Would that code base be more effective for me to manage? Would it be easier for me to find and fix bugs if I reduce the surface area of what I need to focus on? I think that's one of the reasons why functional programming is compelling. I hope these ideas are going to help you when you have that inevitable conversation with the other people that you code with.
Yeah.
People you work with on open source projects, people you work with at your job, people you work with in your class and in school. You're going to have to ask them to go on a journey of learning and convince them to go on a journey as well. And those are some reasons why.
So that'll be all for this video. Take care. Bye bye.